Good evening. Welcome to our next online science cafe. We make it every month at the end of month on Tuesday. And this topic will be dedicated to that what happened right now. I mean, during this month, it is Perseids, the most impressive and the most observable meteor shower in the world. Actually, the reason is correct because of meteor science about meteors started with observations of Perseids. It started approximately 200 years ago. And since that time, people discover many things about meteors, about Perseids. It was Perseids which were connected with a comet. So we now know that parent body of most meteor showers are comets. And so on. So science developed step by step, and we always fascinate about these many meteors which are falling in August. This year, we may see that yesterday, not today, today may be more. Yesterday it was reported almost 15,000 Perseids which were observed all over the world, and you see that maximum of activity happened on 13th of August, practically midnight of 13th of August, and the maximum was around 75 meteors per hour. What does it mean? Here we have zenith per hour rate. It means that in theoretically achievable position, when meteor shower comes from zenith, so the radiant area from where it comes is in zenith, and at the same time meteors are falling in the dark sky, so limited magnitude for observations should be not even 6 as commonly expected for human eye, but even better 6.5. In this case, we will observe 75 meteors during an hour. So that's what this number means. 75, not all of them are bright. Some of them are dark. Some of them are, dim. Some of them are very dim. But generally, despite of that, some we will see for sure, but they are seldom, and others, there are many of them, but we don't see. So we will see around 75. So that's what this number means. And we see that generally it looks like, yes, there is a sharp peak maximum, and then it goes slowly further. If we look who contribute to this 15,000 meteors, we will find out that not the whole globe observe it. First of all, it is Perseids. It means that radiant is in Perseus constellation, which is not far from North Pole of the sky. So that's why for people who live in Southern Hemisphere, it's not achievable. It's not big deal to observe it. So only those who watched on the Northern Hemisphere will enjoy it. But it is August. In August, we have long summer, long days in summer. And that's why those who live at the far north, they experience white nights. So they still could not observe. As a result, only this arrow, not arrow, wide enough, but ribbon on the Earth is available for Perseids observations. At the same time, there are billions of people who live there, so it's enough for people to observe. You may notice that International Meteor Organization collected data not all over the world, but the United States, Europe generally. This is Europe. Yes, it's in Africa, but it is part of Spain. It's Tenerife. And some people in Korea and even in China observe it. So that's what we have. As a result, look what we have when we look at peak in details. So Perseids peak. This peak is collected from 22 or 13th of August till midnight of 14th of August universal time. Obviously, why we use universal time? Because of in each part of the world, it could be different time and could be night at Greenwich, but daytime there and vice versa. And we see that there are gaps in observations. So here we have gap, here we have gap, here definitely not maximum, here definitely not maximum. We have something around maximum, but we don't know, maybe maximum was here even. So what from where it comes? Look at how observers are distributed. They are not evenly distributed on the planet Earth. There are many here, here, and there are gaps. So this gap is obvious. It's Atlantic Ocean. No one is there until you put special ship and observe from it. But it's not long, actually, because of those who observe at Tenerife till morning. Meanwhile, those who start in Canada at evening, they may overlap the observation. So, in fact, this gap is large, but it's not dramatic. It's possible to overcome it. This gap is important, and this gap, Pacific, it's important. In Pacific Ocean, we have nothing, no one here, and Alaska and Kamchatka are not available because of its white nights there. So this is really lack for all observers, and this gap has traditional linguistic barrier. Most people who are here are speaking Chinese and Russian. Both languages are present in United Nations, but they are practically absent in International Meteor Organization website. As a result, people who speak these main languages on the world, they don't supply their data just because of no one there speak English. And that's the reason why we have this gap. So if we develop International Meteor Organization site, so local languages, at least those which are present in United Nations, if they will be available at that website, then people will start supply their data, because of, I'm sure there are observations here, they're just not available for International Meteor Organization. Okay, my topic generally is about concept of how to involve newcomers into Perseids observations. It is inspired and checked, it was inspired by Stanislav Korotky. He worked at least in Ka-Dar, its private observatory, and he gave talk about how to make observations for methods of astronomy. And here in the KITION Planetarium and Observatory, every year we make Perseid observations with newcomers, which are important for science. And we should make short instruction how to make it, and I want to share the ideas of such instructions. So anyone in the world could copy this concept and make it in their own place in Northern Hemisphere. Okay, let's proceed. Actually, it's about Perseids, but the concepts are so easy that it might be applied to any other meteor shower. So in planetarium, we made for science 2 observations, one on 11th and the other on 13th of August. Yes, both were not next to maximum, but very close to it. And we will have enough meteors for our observation, so it's still good. We made 1 hour training. And after that, we made 1 hour of observations. Here it's written per time of 1 hour, but I'll discuss later, explain what's the difference between just 1 hour and 1 hour per time. So first of all, we explain what is brightness of the celestial bodies. Because of its short train, we should not discuss much. We should just give samples. There are many ways how to discuss brightnesses of luminaries. In many cases, amateurs of astronomy already know this language. What does it mean, brightness and star magnitudes? But nevertheless, we discuss it in such way. We show some triangle, in this case Vega, Deneb, Altair, and we mark Vega has brightness which has name, which is defined like 0. Brightness of Deneb and Altair is 1. After that, we show samples of stars which have brightness 3, 2, 4, and so on. So we just show these stars and explain how to find them. In fact, it took some time, but was very simple to remember, to memorize. And Hasret, present here, she was at one of this training. Correct, Hasret?
Yes.
Yes, and we choose a line along swan from tail to head. As a result, tail Deneb is 1, head Albireo is 3, and in between is 2. So we have 1, 2, 3. In between 2 and 3, in the middle and a bit closer to 2, there is +4. On this line, there is no 5 and 6. They are parallel, 5 and 6. And then if you look on the sky, there is nothing brighter than 5 at this area. And then you have to continue a parallel line and for 3. And there is only one star, 6. We dedicate a lot of time for people to be accustomed to this 1, 2, 3, 4, 5, 6. They have to find out the stars, they have to memorize that indeed 2 is definitely brighter than 4 and so on. We needed because for scientific observation these days, the main contribution of amateurs of astronomy is just to count meteors and to give brightness to each of them which they observe. That's enough. Because of more specific things, up to spectrum of a meteor, are for scientists themselves. So for amateurs, this is enough. And I found out that the best way is just to point, this star has brightness 2, this star has brightness 3, and so on. And this person should just remember that. That's all. Well, then we train. Here is another image with taken with under the conditions, and Vega, Deneb, and Altair are not so bright. And after that, people has to find brightness 3. Oh, sorry, Altair is here. Vega, Deneb, Altair. So they have to find brightness 3, and then we have this line. 1, 2, 3. In the middle, nothing but closer to 4. To 4. Then here we have 5, the only bright star here, and 6 is next dim already star. So here people have to train themselves. And what they have to do when a meteor passes, they should compare the brightness of a meteor with brightness of this 1, 0, 1, 2, 3, 4, 5, 6 stars. And how close, that will be the answer. So that's the way. That's what I like, especially on the second session on 13th of August, that people, after such train, they identify very precisely, very good, the brightness of meteors which they pass. I was impressed, just from no previous experience, but very good result. Well, next important point is limited magnitude. Of course, astronomers distinguish the conditions of observations. When the sky is illuminated very bright by light pollution, then not many stars are visible on the sky. And the dimmest star which is visible under such conditions is a limited magnitude for human eye. It should be measured in zenith. This is the sky. On the sky, we have horizon, and in center, there is zenith of this map. And I use StarCalc. It's very quick and simple to explain and to apply. And as you see in zenith, we have swan. It is at around 23 o'clock in Cyprus. So exactly what we need. We will make observations at around 23 o'clock. In zenith, there will be a swan constellation, and it is swan constellation on which we train, because of limited magnitude, should be taken from zenith, where the least sky light pollution is present. So that's why we train on swan. Well, next point. Yes, indeed, in zenith, there is swan. Perfect. Next point, where people should observe. They should look on the sky not very close to horizon, because of if you will generally look somewhere near horizon, part of our field of view is on the sky where meteors fly, and part on the horizon where we definitely don't expect a single meteor. So it means that we are wasting our time. Half of our observation is useless. So that's why we should look somewhere high enough. And we recommend, we just indicate, there are, we have in planetarium course where we explain how to choose the center of field of view, but here we don't explain. It's just 1 hour train. We don't have much time to give all this. We just propose, look at Altair. You see Altair is high enough, 10, 20, 30, 40, 50, 60, 65 degrees over horizon. It's really high. So when you look there, you don't see horizon. So it's good. So that's what is necessary for us. And what's important, let's return back. We have Milky Way. You see many, many stars here. They are passing in this area. So, and Perseids constellation is here. And when we look in this direction, mostly, this is our field of view. We don't have Perseids, but all meteors which are coming from Perseids are coming along Milky Way. And we went to dark area, so Milky Way was clearly visible, and it is additional recognition for Perseids. So everything which fly along Milky Way from behind head, they are Perseids. All the rest are not. So very simple way, and very simple. We just point, look at Altair and everything around. That's all. Well, let's go further. When they look at Altair and everything around, of course, there is the stars look dimmer than those which are at zenith. Let's make a bit of calculations. When M0 is proper magnitude of a star, so the way how it looks in zenith, where there is no EMS and it is proper magnitude, then the real apparent magnitude M will be calculated according to this formula, where K is extinction coefficient and X is EMS. It's just 1 over cosine of angular distance from zenith to the point where we are. So let's put our values. When we are looking at our stars which we used for comparison, we have Deneb or Altair, itself or Vega, or very close to zenith, other 2, 3, 4, 5. So all the stars have different distance from zenith, approximately like 10 degrees. And our Altair is 40 degrees distance from zenith. If we put everything in our formula, we will see that the difference in magnitude is expected like 0.1 magnitude. It's practically nothing in especially for beginner, and most observers would not recognize, would distinguish this difference in magnitudes. So it means that when a meteor fly near Altair, it looks dimmer than in reality, but the difference is 0.1 magnitude. Our accuracy is just 1 magnitude, so it's practically nothing. So could be ignored. So it's good that when people observe here, we don't need to explain that there is air mass, we should apply this formula and so on. Forget it. It's good. Next, equipment. We told everyone in advance that they need, I used to say chaise-longue, so folded chair, let's say. This is the most important part. All the rest we may give to everyone, but this is we could not give. So when people gathered, and we had up to 20 people in each session, so each of them, I was very proud that each of them had their own folded chair or anything like this, so they were comfortable during observations. Because if you could not observe the sky for a long time if you are not comfortable with your position. So we need carton paper like this. We folded it like this. And we need 2 pencils, obviously 2, because of one you may lose occasionally. And you don't want to waste your time while you observe the sky, so just take 2. We need red torch. Usually 1 red torch for the whole group is enough, but anyone could take their own. We need comfortable chair already. Clocks. We organize it like this. 1 person follow time. So announce to the whole group that now it's 22:55, and our session was 15 minutes. So everyone wrote by themselves 22:55 beginning of session, and that's all. So clocks were 1 for the whole group. And when 15 minutes pass, there is a signal, a robotic signal that time is elapsed, and end of session. And of course, we don't want to feed mosquitoes at least much. That's why closed clothes and shoes are necessary for observations. Well, so that's what we need, and we told about it in advance. So those who signed and informed that we will come, they read this requirement already. So we gave to everyone this short instruction of what to do, which are helpful for submitting and enough for submitting the observations to international meteor organizations. So here at the bottom there is the web address of it. So here we have names of stars and their values. So let's start again. 0, 1, 1, and Elon's 1. Elon, it's from head to tail. We have all the rest. 2, 3, 4, 5, 6. So all stars here. Well, and we give recommendations. General, it should be in dark areas during astronomical night without moon if possible. Yes, while we made observations, even on the 13th, the moon set behind horizon. So this year it was excellent. But because we know that people will keep this piece of paper with them next year and next year, that's why we wrote without the moon if possible. Sessions, 15 minutes and 5 minutes break. So we make observation and we take some rest for our eyes to rest And after that, our concentration will be again returned to the sky. Center of the field of view, we propose Altair. This is official name, Alpha Aquila. And these are coordinates which are necessary to be put in International Meteor Organization report. So we already gave them in the form how they wanted. They wanted in degrees both values. So they are given. We don't describe, we don't explain what does it mean alpha, what does it mean delta. It's here and that's all. So for those who wants to start, it's okay. For Perseids, it's well. But if you want to continue, you're welcome to do other things with us or without us or whatever. So you may learn more about it, but it's next step. For beginners, it's excellent just to inform them. These are the numbers. If you look at Altair, this is the numbers you have to put in your report. Abstractions, if there are no abstractions, then value k equal to 0. Or if you have clouds or some trees or roofs or whatever, then it is 5 or 10%, something like that. Well, limited magnitude is the dimmest star overhead, so it's general definition, so in zenith. In our particular case, you know, we choose Sven not arbitrary, but because of it is in zenith in Cyprus. So that's why when they choose which one is, which magnitude should be here they are. They will. They're already prepared. So we made this basic work in advance. Then observed meteor, either it is Perseid or sporadic. So on samples of photos, we already explained what does it mean, Perseid and sporadic. Well, method of observations, yes, in this particular case, we just count. So that's why method is counting. All this will be required for International Meteor Organization report, and all these data are here. And records, brightness of meteor, and its type, Perseid or sporadic, and no more than 20 meteors in each session. So that's what we did. Okay, so we gave this data. Where we went? This is a light pollution map of Cyprus, data collected in 2022. And you may notice that here is Larnaca, here is our planetarium, and it is on the edge of light pollution. It's better conditions exactly where we are. And if you go outside, you will see that indeed it is essentially dark than around. So we are here. But it's not the best place. Limited magnitude here is 5.5, so between 5 and 6. So it's still not the dark sky. That's why we went to another area. Let me see. Here is our map. Here where we went. So we were at this place. So as you see, it is closest to us, dark place in Cyprus. Another one we used here a few years ago. I don't remember when. Right now, I don't remember. But we use another place here as well for some time. I like it as well. It's nice. It's really dark there. So these are nearest dark areas which we choose in Cyprus. This map, here is the name of the website. So just use it at the site and choose by yourselves your own dark area. So we arrived there by cars and we made observations. During observations, the director of Planetarium, George Trulias, he made preparations of his camera just in case it's possible that on his camera there will be visible some tracks of meteors. So this is one of his result from this year observations. I did not find any meteor here. Oh no, could be this one actually. I saw it right now. Maybe this is a meteor. If it's not, it should not be a plane. So maybe we have meteor. Okay, anyway. while he made these preparations, meanwhile, I worked with the group because we had already Sven overhead, so we trained on stars themselves. We found out from where meteor should fall and how it should fly overhead from behind head in along Milky Way. Milky Way was perfectly seen. Hasret, was Milky Way visible? You was at the observations.
You mean the area that we have gone together?
Yes, on the 11th of August.
Yeah, it was visible, but because I have gone to it was not so clear.
Okay, so you know better places.
Yes, I have gone to Poland, Krakow.
Okay.
And there it was very nice.
Okay, so you see, this is the nearest to us, but it's I did not say that it is the best. So maybe next time we'll go to another.
Okay, yeah.
Thank you. So while George made these preparations, we became accustomed to darkness. We saw the sky. We find out the limited magnitudes and all other stars which are necessary for our observations, and then session starts. These are results. Let me stop at the moment. So when session starts what we did. I wrote, so we have this piece of paper, and I wrote first the date, for example, from 13th to 14th of August 2024. So this is my very first line I wrote. Then I miss few. I just was not sure whether here was written something or not, so I miss it. Okay, doesn't matter. Then it's written 23:43. You may guess that it is time when we started our session. I never write end of session because of it's always 15 minutes. So I may count by myself. I never write it. After that, I wrote center field of view, but it is for me. For others don't need to write. It's written at the leaflet, which were given to them. All of them look at Altair. I did not look at Altair just because of why. Everyone is there, so I look at another area on the sky. And after that, here I wrote, for example, 4S. It means that I saw meteor brightness 4, and it is sporadic. It's not Perseids. And next one is, after that session ended, this is my symbol for end of session. So 2 lines. And then I wrote limited magnitude, and I wrote 6. So I saw 6 limited magnitude. And then there is 0% at the end. 0% means obstructions, so I did not have obstructions. All this was written with a pencil without looking on piece of paper. So how it goes. For example, I'm here already, it's at the end. So I keep everything, all this part in hands. I wrote something. After that, without looking, I turn to the next page and write down further. Turn to the next page, small piece of paper, and write down further. Very simple. It's very easy. And you don't look what you are writing. You have 5 minutes break. During that time, you might check what was written. Sometimes your 5 look like 6, and you may correct because of right now you remember. In a week or especially in a year, you would not remember that. So that's why it's good to check. And I saw how that many people during 5-minute breaks, they indeed check what they wrote with red touch. So let's look at the results. I took result of Dmitry Dubishkin, which he presented not this year, but previous year, and you may see how it goes. He made 15 minutes observation, so we had 4 sessions with 5 minutes break. Look, it ended at 15 minutes and started at 20, ended at 35, started at 40. Indeed, there are 5 minutes break. And he looked at exactly that star Altair, the first value and the second value, both are given. He did not have any obstructions, So F0, F100, so obstructions are 0. And his limited magnitude was 5, so he found the dimmest star. So he did not see the star 6, but he saw star 5. So that's why he wrote 5. He just counted meteors, letter C means counting. And in first 15 minutes, he saw nothing. In next 15 minutes, he saw nothing. In next 15 minutes, he saw one sporadic. And at the last, finally, he saw 2 Perseids. You may ask why, what happened? The answer lays in date. It is the 8th of August, and maximum is around 12th of August. So he was far away from the maximum of activity. That's why he saw just few Perseids. And here, it's the first part, how many, and the second part, how bright. So when he had 2 Perseids, one of them was brightness +2, another brightness +3. So one looked like the head of the swan, and the other like conjunction in swan, so +2. And sporadic was really bright, like Deneb itself, +1 magnitude. So here we are. Here his report. This is the place where he made this observation, and that's what we have. So that's how results look like. And I want to show you results of Stanislav Korotky, from the person from whom I started, who inspired me to make all this explanations to newcomers later. And let's look how his observations looked. Again, he observed Perseids and sporadic. There were 2 and 1, 1 and 1, 2 and 2. Again, it's not around maximum. It was for 9, 10 of August, so that's why not many of them. And look, he made 15 minutes observations, but here it's 15, but in fact he wrote a bit shorter, a bit smaller, because of few minutes out of this 15 were lost for some other activity. For example, a plane fly in the sky and it disturbs you, or whatever. So that's why a bit smaller number is here. But he made break, and after break, he observed during next 15 minutes. Again, he made break, and this time you see half an hour break brought to new conditions of the sky. Before it was precisely dark sky. 6.5 is dream for dark sky. But after that, limited magnitude became 5, and obstructions appeared. So most probably he experienced clouds, and you see a switch from a field of view, one type of coordinates to another type of coordinates, shows that most probably during these 45 minutes, that's what happened. Despite of worse conditions, he observed more Perseids. So it means that they increase. And this is the brightness distribution. So that's what is necessary for amateurs of astronomy without essential preparations, what they have in their hands, to make their contribution to science. That's what is necessary, just during which time you observe, how many you counted, and which brightness are they. All the rest, more sophisticated observations, could be conducted, and they do conducted by specialists with special equipment. So but this is valuable data which amateurs could do. Well, anyway, I mentioned now Dmitry Dubishkin, and right now he is not in Cyprus. Right now he is at International Olympiad on Astronomy and Astrophysics in Brazil. And he is with other students, 5 students from Cyprus, 1, 2, 3, 4, 5 of them. And one of them got Katie, are you with us? Yeah, good evening. Do you teach ARA?
Yes, I do.
So can you say a few words?
Well, we're all of Cyprus is very, very proud of ARA's achievements. It's a good team effort. and he's just amazing. You know, he worked really, really hard for this, and we're all extremely proud of his achievement, and it puts Cyprus on the map. It really does, and congratulations to everyone who's been involved with him.
Wait. You explained, you said everything about explaining.
Without explaining what he did?
Yes.
Okay. Right. He's basically achieved the gold International Olympiad, which is a really, really great achievement. Very few people actually obtain the gold because there's certain cutoffs. So everyone takes part in the Astronomy Olympiad. They have fun, they solve problems, they do visuals, they have group exercises, and at the end of the day, it's a lot of it is marked and graded, and there's several honors that they can attain: honorable mention, a bronze medal, a silver medal, and top of the top is the gold. And Ara actually got the gold medal, so congratulations to him.
Yeah, great. Well, and it is his second gold medal at International Olympiad. Previous year he got it as well. And it is he who started bringing medals to Cyprus.
Yeah.
Actually, our contribution to Cyprus education started with Kition Astronomy Academy from a request of participants of International Olympiad to help them with training on to prepare for the Olympiad. So that was the beginning while we developed this course of Kition Astronomy Academy. And Ara and two other students out of 5 team of Cyprus this year were at this Olympiad. So it's again good achievement. And starting from this Kition Astronomy Academy, Cyprus began to bring some achievements from International Olympiad. So the first was honorably mentioned by Hracha. Then there was Stellios, who brought honorably mentioned. And there was one more person who didn't study with us, but who is good in Cyprus and who brought honorably mentioned as well. I don't remember if there was one more student who does study at Kition Astronomy Academy and got honorably mentioned. I think there was one more. So
Stellios, Hracha, and well, I'm just talking about the students that I'm aware of. So I know from our school, from the school, that it's Stellios, Hracha, and Ara.
And Ara, yes,
Yeah,
the 3. And I remember there was one more out of the 3, and maybe one more. So Cyprus got 5 honorably mentioned in the whole history. For sure, maybe 5, I don't remember. And 3 were students who studied at Kition Astronomy Academy. But Ara overcame this later. He brought bronze medal, after that gold medal, and this year again gold medal. So really incredible. Well, that's why I have to explain what does it mean Kition Astronomy Academy, if we started with it. We have 3 levels: primary school, gymnasium level, and lyceum level. At each level we teach 3 years. So the first year is introduction. Next year, with small children, we discuss analemma, we discuss angles, we make practice with angles. Because of angles in common school are not for primary, it's studied in gymnasium. But we use angles so often and so widely in astronomy that we develop special concepts, special way how to explain children what are angles, and we practice them constantly. And the 3rd year we use astronomical programs and so on. So if I will discuss all these details, I might spend all my time here, and you will be involved here, interested, but too much. Enough. The gymnasium level introduction is enough to participate at Cyprus Olympiad on astronomy and astrophysics. So we use homework there, and homeworks help to repeat the knowledge gathered during meetings. And we have a result, for example, this year, a student just come from gymnasium. He just come for the first year for introduction, and he got a silver medal at Cyprus Olympiad. So it works. I'm talking about Michalis Vimiotis. So generally, we may consider like preparation to Olympiad, but generally it's useful just by itself. We have some students who don't participate in Cyprus Olympiad, but year after year they participate in this course, they study there. So next year is more sophisticated astronomical phenomena which are not touched in introduction, such as dusks, such as refraction, aberration of stars, and so on. So many interesting topics, but we could not put them in introduction. Then we discuss astronomical concepts the third year. This time we apply International Olympiad tasks as samples of what we discuss, and we begin our theory of errors, which are constantly applied at International Olympiad without any excuses. So it's a very high sophisticated level. Astronomy Principles is a course which designed for Lyceum students. So again, we have introduction for the first year because of many students just come from beginning. They did not pass all these introductions before. They didn't study with us, so they have to learn the main terminology in astronomy. The next year is more sophisticated. We discuss energy, angular momentum, which is constantly used at Olympiads in physics and astronomy, but not in school curriculum mostly. And we discuss concepts of elementary particles. Each year, it always starts same: astronomical instruments, solar system, stars, galaxy, cosmology. So all the same, but it's more and more and more advanced each year. And the last year we apply calculus to tasks which could not be applied before, and I found it enjoyable for students. Spherical astronomy, completely new topic, completely new tool, and we applied there. We developed curved space-time, and we developed theory of errors at very high level, so high that even concepts of this level are used at our scientific seminars, which we held in Kition Astronomy, in Kition Planetarium and Observatory, separate part of educational part. So that what going on with our course, and it is that how students got such results. Actually, it's really incredible because there are 7 billion people in the world. There are just 1 million people population in Cyprus, 7,000 times smaller. And even to get honorably mentioned at International Olympiad, it's much more than just statistically 1/7,000th part of the world. And if we start repeat it constantly, it means that this course was developed fine enough. Well, and at all of them, at each year, we discuss archaeastronomy, history of astronomy. All this is necessary for people to find their place. Why this knowledge appears this moment and not later, not before? Just because of the progress of humanity allowed to discuss such tasks at that age, at that period of human evolution. So these concepts help students to find out the reasons and the places of each achievement of humanity in astronomy. So that's how the course of developed, and the this course is only here in planetarium, but all the rest, World of Astronomy and Astronomy Principles, are available online. So Ara, for example, he is so talented not only in astronomy, but in physics and mathematics, that for him to go from Nicosia to us and back, it's 2 hours to lose time. So that's why, just to save his time, he study online. Well, for those who wants to make their own develop themselves when grown-ups, we have Read the Sky, where we discuss the names of stars which are used, for example, before you saw at that leaflet we gave to people, so Deneb or 17 of Cygni and so on. So from where it comes, so all these coordinates, how to read star maps, all this is discussed at Read the Sky course. And the Sky is Alive is the course more sophisticated. It is for those who already passed Read the Sky, and it is how as a matter of astronomy may make contribution in science. Not just enjoy the sky and being a matter, but make something valuable, which is important for astronomy as science. And here you see some meteors shown. Because of one session, it's 4 sessions, and one session is dedicated to meteors, to meteor observations. And if you saw already at Perseids training, we don't discuss many things which are lying away from the topic. We just point, look at an Altair, check these 6 stars. If a meteor like this, it is that brightness, so write that brightness. So we just give instructions how to do without explaining many details. But at that course, much more interesting things go. So because of its course as basement for meteor observations. Well, so that's what we have with the educational part. There will be interesting event during this month. We will have full moon and Saturn next to each other. It's obvious because of Saturn is in a position, so it's opposite to the sun. And the full moon is always when it is opposite to the sun. That's why the moon and Saturn should be close to each other in September. This is obvious. But that what make thing really interesting and intriguing is that we would not have just full moon. The moon will be close to the Earth, and this phenomenon is named supermoon. So we will have supermoon and Saturn next to each other. So this conjunction will be on 17th of September, and you may take a photo of it. We will make public event with observations, with telescope observations, and tickets are still available there. Well, your questions.
Colin, former of the academy, but he's having some issues joining. So Stellios is in he's trying to join, but I don't know if he's going to make it.
No, he's here.
Oh, is he?
Yes, no, he's connecting. He's connecting, yes.
He is, okay. Yay.
All right.
Hold on, I can't. Can you see me?
Yes, I see you.
Okay, good.
Wait. I'll stop sharing.
Yes.
Now let's proceed.
So yeah, so Stellios, I'm glad you could figure out how to join us.
Yes.
We had well, you know, as you know, we've had that success with our,
of course, yes,
the gold medal, and it's just lucky that you popped online because you've actually won honourable mention at the Olympiad as well. So here you are. Would you like to say a few words about it?
Well, it's been already 5 years.
Yeah.
No, actually, it's been 4 years. 5 years was the first time. Yeah. The second time was when I got the honourable mention. And it's I mean, I had to make a huge effort to get the honourable mention. It was that was after I'd already graduated, actually. So that was very difficult to achieve, and it took quite a bit of effort. So you can imagine how big of a success it is for someone who's actually a bit younger than I was at the time to get gold, which is so many, well, not so many, but is significantly higher than the honorable mention, because you obviously above that you have bronze and you have silver and then you have gold. So that's obviously tremendous success for Cyprus, but also for ARA individually.
He might choose any place to study.
Yes, exactly.
Where are you studying, Stelios?
Yes, well, I should say that given that, I'm studying at Cambridge, University of Cambridge, but given that the honourable mention got me in that, okay, obviously there were other factors that were taken into consideration, but just imagine someone with gold.
Yeah, of course. No, actually, honorably mentioned really achievement, because of it means that you did not just participate. Cyprus is a small country.
Yes.
And, as I already said, but you did not hear it, you just now joined.
Okay.
1 million population with respect to 7 billion. It means that from nowhere to choose. That's why just to participate doesn't mean much. On international scale. But if the person is among 2/3 of the best in the world, then it means that that person made much more efforts than just participate.
Yes.
So that's the reason why, starting from honorably mentioned, your university already.
Yes, quite, yes.
Because of being just participation, so what? From Cyprus.
Yes.
Maybe participation from developed countries, from large countries like India or United States or whatever, there could be, because of its to participate out of many millions people, population is already means a lot. But for Cyprus, they did not. Well, in that particular case.
Yes. Although I hear that now there's more people who try for the National Olympiad than there was in my days.
The level become higher.
Yes.
Because of you.
Well, not just me singular, definitely me plural, because, well, not me plural, but us plural, because there was, of course, Hracha before my year who got the honorable mention.
No, they started increase after you. I mean, after you.
Okay, sure, yes. And then
because
in my year, we were 2 of us, and then...
Yes, because of it becomes obvious that, yes, you increase level, and they have to choose... They will choose same way, but okay, I'm not there. Anyway, I do, while during my course of Astronomy Academy, I check what's going on now with the Olympiads, and I have to explain children and embed the ideas in my course. And I see that, yes, now it's much more advanced. Before it was, who invented telescope? In which country it was invented? Come on, they stop us such questions at all. But similar things happened actually in International Olympiad.
Oh, really?
Yes, because of if you open the International Olympiad in 2007, the very first, they didn't know what to ask. They didn't know who will come, which level the preparation will be. And they ask questions which I have. Just imagine, at the Olympiad, they ask questions which I have as a test on astronomy for students.
Yes.
So it was just regular question. And it was even just mark correct answer. So it was not just thinking. It was just, you pass it.
So you're saying that it's even more difficult than, than 2008, as you say, but has it increased since when I went? Because I remember when I went.
Yes.
That's really interesting, because when I went, 2019 and 2020, they were very tough.
Yes, but now they, for example, sometime later they introduce cosmic strings,
Okay. Oh, wow.
and I had to put cosmic strings. Could you imagine in my course at the last year in cosmology? I even developed cosmology in a way that students will start with special relativity in school.
Yes. Yes.
Finished with general relativity, apply it to cosmology, and we will make many applications. Gravitational waves, it's constantly on the International Olympiad.
Okay.
Then what else? It's one type. Another type, black holes, and not just we discuss the generally, so not we discuss metrics.
Oh, yes.
And out of the metrics comes this event horizon.
Oh, I see.
Formula for event horizon
Yes.
could be explained even to a school child without anything. Just
Yes. You mean
just
you
like
derive
this.
it. You don't just teach
Yeah,
it to them.
yes. But
Yes, I see.
now when they know concept of curved space-time and they know how to express it, and after that we start to have examples of this. If you express the curved space-time of a black hole look like this, the curved space-time of the propagation wave, gravitational wave look like this, and so on. And after that, when you look at International Olympiad and they gave you formula which exactly was like 5/32 coefficient, but we just now derive it.
Yes.
So at Olympiad, they don't have time to explain, they just give
Yes. No,
you.
of course. Yes.
But we had time and we got it from the general concept. And then we embed the gravitational, the cosmic strings as well.
Yes. Oh,
Formally, it looks simple, and because of it looks simple, that's why it
Yes.
was embedded.
Yes.
But to cosmic strings, we dedicated 2 meetings, not just one. All the
And
rest
you're saying that it's quite quantitative as well. It's not just qualitative.
Yes, of course. They have to count, to calculate, and so on. And even with this course, I did not have time to discuss some topics, energetic topics of cosmic strings. So I discuss only kinematics.
Okay.
But anyway, I should not cover every task.
Yes. I mean, energetics of cosmic strings is not something that presumably they'll do until if they go on to universities. That's something that tends to appear in like the third year.
Why? It should be the 5th at the end. Come on. General relativity, you will study at the end.
Extremely specialist.
No, well, yeah, I mean,
what? You have to develop a Riemann geometry. How will you do it? It's at the end of the course. Come on. Very end.
I do have question, and maybe Stellios, you can add to this. Like,
yes.
I was watching the closing ceremony with the physics staff in my department, and they were like,
yes.
"What is Iran doing? Why is Iran so successful?"
Yes.
Oh, I see. Yes.
Yeah.
Well, in my case, when I went, what was interesting about Iran, well, they got silver medals. I remember quite a few of them. A lot of them were actually in tears because they hadn't got gold. So I think some part of their success comes down to an attitude that nothing less is acceptable, which is not healthy.
No.
Absolutely not. And I don't care if it yields good results. You have to question what the cost of that is. I don't exactly know how the education system in Iran works. Iran has a huge tradition of astronomy dating back to
Babylonians.
the 5th millennium BC or so. And it's not what I would say is it's not, I would suspect, is not irrelevant. I perhaps wouldn't say it's relevant, but it's not irrelevant, double negative, getting into logic now. So perhaps that's part of it. It does also seem to be the case that in Iran, knowledge does seem to be, or knowledge of this sort, does seem to be valued quite highly. It's not, you know, I guess the free market doesn't work in the same way that it works in the West. So technocracy might have more of an importance. But again, this is a hypothesis. I don't know. The Iranians, whom I met in 2019, they did socialize to an extent, much more than a lot of other nations, but they did make it quite clear that, well, we're here to get the medals, we're not here to have fun, which is what was the opposite of the attitude of the Cypriot mission, I felt, for example. Now there's also this interesting thing that I heard from someone who'd been told by someone who'd been told by someone. So please take this with, not a grain of salt, take it with a ton of salt. But what I was told is that in Iran, and this shows you again how much knowledge is valued, I believe they give the men exemption from conscription if they get a medal at some international Olympiad, and that's any medal, doesn't have to be gold or anything. So I don't know to what extent that is that helps. I don't know to what extent it motivates people to do better. I think it puts them under stress. But as you said, it does seem to work, if we can use that term. That's, I think, as much as I can say. What I would want to reiterate is, whatever they're doing, I don't think it's healthy.
Okay, thanks.
My pleasure.
You see, in our Astronomy Academy, I constantly take care not to, how to say, I may say it in Russian easily. Well, anyway, not to not inspire, but something like, let's say, push a child to participate in Olympiad and obligatory do something. No obligations. The child is here because of he likes astronomy. Finish.
Yes.
Yeah, that's what it should be.
And all the rest doesn't mean anything. I have, for example, a student who did not participate in Cyprus Olympiad. Then she did not participate next year. So what? Yes. I still love her. I still teach her. we still make many things about it. So what?
But that's why we're successful, because of that attitude. I mean, it's healthy.
So there most probably there is an enthusiast in Iran, top enthusiast, who is responsible for education of these talented students, and most probably it is his projection of altitude. He needs results or whatever. That's what make it like this. Okay, so it's just question of, yes, it's important question of psychology, but for me it's really important what's the main reason, especially for child.
Yes, no, definitely.
Yeah, I agree.
I saw very different attitudes between different countries when I went, and some were certainly I felt much more healthy than others. I was complaining before we went when I was doing the practice here with the Cypriot team. I was thinking, okay, you know, at least some of these people are not particularly interested in the astronomy of it. They're just going to have fun and, you know, do other things perhaps, but it wasn't very much about the astronomy. But I left, this was when it was in Hungary, I left thinking, well, you know, that's a much better attitude than other things I saw there. There was quite a bit of toxicity within certain groups. I mean, generally the European and American teams had a generally laid back attitude. They did want to do well, of course, but it's one thing. And then you went to various Asian countries where the work ethic was much less healthy, I felt. I don't want to make it into an East-West sort of despotic Orientalism, 19th century box standard view of the East from the West. That's not what I'm trying to say, but it was an interesting observation that I made. And I don't want to make it into an East and West thing. I can give you, you know, examples of exceptions from both sides, which they're not sides.
Yeah, it's quite correct.
Okay, so yeah, we can continue this discussion later, can't we, Stellios?
Yes, quite.
Okay, let's return to our finalization then. So
Yeah.
our next Science Cafe topic will be announced later. It will be as usual on Tuesday, the last Tuesday of the month. So in September it will be 24th. Time is always from 20 o'clock Cyprus time, and just sometimes it's UT +3, sometimes UT +2. So in September it will be +3. So see you again at next Science Cafe.
Bye.
Wait, I'm turning off.
Bye, thank you.